Hello there, welcome to the show. I hope you are doing well. In the previous episode of the series, we discussed two types of chemical reactions, known as combination reaction and decomposition reaction. Today we are going to discuss three more types of chemical reactions, known as displacement reaction, double displacement reaction, and redox reaction. In the previous chapter, we discussed combination reaction and decomposition reaction in detail. So, let's jump directly to the next reaction. The third reaction is displacement reaction. A displacement reaction, also known as a substitution reaction, is a type of chemical reaction in which one element or group of elements is replaced by another element in a compound. It occurs when a more reactive element displaces a less reactive element from its compound. The less reactive element is just pushed out of the compound and is often in the form of cation or anion. Reactive elements can be defined as the compatibility of both elements to form bond. The more compatible the elements will be for each other, the more readily they will form bonds. Displacement reactions can occur in various forms, such as metal displacement reactions, halogen displacement reactions, and redox reactions. Here are a few examples to illustrate different types of displacement reactions. First one is metal displacement reaction. In a metal displacement reaction, a more reactive metal displaces a less reactive metal from its compound. For example, zinc reacts with copper sulfate and displaces copper from copper sulfate, resulting in the formation of zinc sulfate and solid copper. Second example is halogen displacement reaction. Halogen displacement reaction involves the displacement of halogen by another halogen in a compound. For example, chlorine reacts with sodium bromide and displaces bromine to form sodium chloride and liquid bromine. These are examples of displacement reactions. Displacement reactions are important in various fields, including metallurgy, electrochemistry, and chemical synthesis. They help us understand the reactivity of different elements and provide a mean for obtaining desired products through the replacement of specific elements in compounds. The fourth chemical reaction is the double displacement reaction. It is also a type of displacement reaction. A double displacement reaction is also known as double replacement or metathesis reaction. It is a type of chemical reaction that involves the exchange of ions between two compounds. In this reaction, cations and anions of two different compounds swap places, resulting in the formation of two new compounds. The general form of a double displacement reaction can be represented as AB plus CD, producing AD and CB. In this equation, A and C represents cation, while B and D represents anion. The cations and anions combine to form new compounds, AD and CB. Here is an example to illustrate a double displacement reaction. In this reaction, we can see that sodium chloride and silver nitrate are reacting. In the process of reaction, chlorine and nitrate swap their places and produce two new elements, sodium nitrate and silver chloride. Double displacement reaction often occurs in aqueous solutions, where the ions are free to move and interact. They are commonly observed in reactions involving ionic compounds such as salts, acids, and bases. Now it's time for the fifth and last reaction. Hence, the fifth and last type of chemical reaction is a redox reaction. A redox reaction is a type of chemical reaction in which there is a transfer of electrons between species. It involves two simultaneous processes, oxidation, which involves the loss of electron, and reduction, which involves the gain of electrons. Redox reactions are essential for energy generation, chemical transformation, and numerous biological processes. In a redox reaction, there are two components. First one is oxidation. Oxidation refers to the process in which a substance loses electrons, resulting in an increase in its oxidation state. It is often associated with the addition of oxygen or the removal of hydrogen from a compound. The substance that undergo oxidation is called reducing agent or reductant, since it causes the reduction of another species. Second one is reduction. Reduction refers to the process in which a substance gains electrons, leading to a decrease in its oxidation state. It is typically associated with the addition of hydrogen or the removal of oxygen from a compound. The substance that undergo reduction is called oxidizing agent or oxidant, since it causes the oxidation of another species. A simplified representation of a redox reaction can be given using half reaction, where oxidation and reduction are written separately. Each half reaction consists of the species involved and the electrons gained or lost. The overall redox reaction can be obtained by balancing the number of electrons transferred in both half reactions. For example, let's consider the reaction between magnesium and oxygen. To form magnesium oxide, in this reaction, magnesium is oxidized to form Mg2 plus ion, while oxygen is reduced to form O2 minus ions. Oxidation reactions have several effects and consequences in various contexts. Here are two of the obvious effects of oxidation reaction. First one is corrosion. Oxidation reaction can cause the decay of materials through corrosion. When metals react with oxygen and other substances in the environment, they can undergo oxidation, leading to the formation of metal oxides or other corrosion products. Corrosion can weaken the structures, reduce the lifespan of materials, and impact their functionality. Second one is preservation and food spoilage. Oxidation reaction can influence the preservation and spoilage of food. Oxidation of fats and oils in food can lead to rancidity, causing undesirable flavors and odors. Antioxidants are often used to inhibit oxidation and extend the shelf life of food products. So till now, we have discussed 5 types of chemical reactions. That's enough for now. In our upcoming episodes, we will be discussing about acids, bases, and salts. Till then, stay tuned. For more information about this or any episode of this series, check out the blog. Link is in the description. We have additional contents, further readings, and transcripts of every show. We have also published our 2 books on Amazon Kindle Publisher. We would love to see your reviews over there. Thank you for coming to the channel and watching the video. I hope you loved the show.